repeating character replacement. So given this character, and then this is our times that we can uh, replace it. So at most 2 times we can replace it. So when we replace it 2 times, what will be the longest repeating character? In this case, we see that we have AA and then BB. So let's say it's like if we replace all these A's with B's or all these B's with A's, then we have the longest 4. In here, if we could replace one of them up to 1 and then find the longest one. So if we replace this with A, then we have 4. If we replace this with B, then we have 4, etc. So the output is 4. So our constraint is all of them are uppercase English letters. The way we're going to solve this problem, we are trying to find the longest repeating character. So when we are trying to find the longest substring, repeating character, longest subarray, etc., like in here, the length of the longest substring containing the same letters, etc. This sliding window technique comes into picture. So let's solve with the help of sliding window. The way we're going to do store all this in our map frequencies and move our window to right if our window is valid. If it is not invalid, then we'll shrink the left side. So let's keep solving this problem. What do we need to have? So we will need to have our for loop with 2 pointers. I will be pointing the right side of it. J will be so I is the right side of the window, J is the left side of the window. It will run until the right side till the length of the string I++. Now we have our window here. Prior starting it, let's have our hash map where we will be counting the frequencies of our character. So integer map new hash map, and we are getting the character of, let's say, C char at I. So the right side of the windows we are getting the character. You can say right char, and we'll be counting the frequencies of it. Put right char and then count the frequencies. Map get or default right char. If it does exist, then return 0 and then increment it. So we are counting the frequencies of it. Then we can keep track of the the longest letters that we have here, the longest frequencies. So let's have our also define our longest frequency, which will be 0 in the beginning, and we can just get the longest frequency by having the max given this longest frequency, because we need to keep track the longest one. So to have the into account when our window gets invalid with this given how many times we can switch to replacement. So that's the reason why we're getting longest frequency number. And then where do we get this longest frequency? Map get right character. So we'll be getting whatever the longest frequency. So here we could say if our frequency, like while our I from right side to j and then +1, because our index starts with 0 and this is at most k times, so this is inclusive, and then we can subtract our longest frequency and then say if this is bigger, even if it gets larger than this one, then our window becomes invalid in this one. Then we will shift our window, shrink left side of it. So how are we gonna do that? We will get the character and then also decrement our value. That's how we will be shifting it. So left character we are getting from map, no, from s char at j, because j is the left side, I is the right side. Then we'll put it into our map and decrement it. So left character, this is already in the map since from right character we have covered it. This character, and now we will be moving shrinking the left side, so this will be in the map, and then we need to decrement it. So map get left character and decrement it by 1. Then we can shrink our left side. So once this is done, because we need to find the longest repeating character, so we need to have our answer as well, which is, you can just say result equals to 0, and our result will be max of result, and the given this I j plus 1, because this is the size of the window. Then we are returning our result. Let's run our code. Perfect. Let's submit it. So time complexity here is of n, where n is the length of the string, because and then for our space complexity, so at most this can take up to 36 characters of English because it's all uppercase, so we can say it's also of one constant.